Okay, so we're talking about composite objects. That's when you put the standard three-dimensional shapes together. This is an example of a dumbbell. So what are the two shapes involved here? Or actually, it's only one shape, but three different sizes. It's like cylinders. Yeah, two different sizes, pardon me. And so just jot that in. Two cylinders and one cylinder. Okay, and then they want surface area and they want volume. Okay, so we'll start with the volume. Volume is way easier, and in fact, you'll come to realize this with enough practice that volume is always easier. So when you're stacking objects together, volume, you just be a total, obviously. Okay, so let's do the volume one first because it's way easier. Okay, so volume is going to be, well, what's it going to be? And I can't go to my formula sheet for this. I have to think. Okay? Let's just come up with a unique formula for this shape. So let's call this shape V1, and let's call this shape V2. So how many V1s are there? There's two V1s plus one V2. Okay, and then on my formula sheet, like, what's the volume of a cylinder? Pi r squared h, right? So we'll just keep this volume of a cylinder formula in the back of our minds. And here we go. All right. Okay, so 2V1. So 2 times, bracket. Now what's the formula for V1? Pi. What's the radius? 12 or 6? 6. We got to square that, 6. And then we times by the height. What's the height? 6.4. Good. Everyone see that at 6.4? Sometimes I walk to the screen, I forget I have a pointer. Okay, so right here, this 6.4, that's the height of the cylinder. Imagine it was like stacked on the base. It was standing on the base, it would go this way up. Okay, and then the distance of the circle, the diameter, halfway would be your radius. Halfway. Okay. Now, let's do V2. What's V2? The small cylinder in between. So we're going to use pi r squared h again. So pi. Radius, what's half of 2.5? 1.25, and then we got to square that, and then we times by the height, which is 14.8. Now, that's a pretty large formula, so when I use my calculator, I'll probably just do one term at a time and then add it up. Okay? Make the screen larger. How about that? Is that better? Okay, so on my calculator, I'll probably deal with this guy first. And then I'll deal with this one second. I'll write them down and then I'll add it up. And I'll take a few decimals along the way so that I'm accurate. Look like 1447.645 plus 72.649, and then 1520.294, and then it wants nearest cubic centimeter. So after rounding, cubic centimeter. So there's volume of this composite shape. And then what I'm going to do, once you guys have it all written down, I'm just going to erase everything because there's not enough space. Actually, I could probably just blow it up. Let me know when you guys are ready on this, and if there's any questions. Oh, one person still writing. Question? You're done? You're ready? Good? Okay. Now the surface area. Okay, surface area is going to be much more difficult. Okay. Let's just jot down the surface area formula, keep it in the back of our minds. Of a cylinder, okay, what are the shapes on a cylinder? You have two circles, top and bottom, so 2 pi r squares, two circles, top and bottom, those are the two bases, plus like the label that goes around, like you know the label on a soup can? Okay, the label on a soup can, of course, you could use a piece of paper that was the perfect size, and you could wrap it around like my water bottle here, and then you got your surface area of your soup can, the label. When you unravel the label, all it does is make a rectangle. The area of a rectangle is just length times width. Okay? The width of the rectangle is the height of the cylinder, and the length of the rectangle is the circumference. Good. And like it says on your formula sheet, circumference is 2 pi r times the length of the rectangle, which is h. So 2 pi r h. Alright. The only problem is that this composite object has issues. Okay, let's blow this up. When you talk about this word here, surface, some things are on the surface, some things are not. So for example, right here, there's a little circle, and over here as well, that are not on the surface. So when I do the surface area of this shape, I'm going to omit two circles. Does that make sense? Anybody? Why would I omit the two circles there? Anybody have any issues with that? You understand it? Because you cannot see them. They're not on the surface. So the surface area of this object in the middle, I only need to use this guy. It's just the label. Okay? So right underneath this, I'm going to write surface area. I'm just going to put mid here, just to help me remember where this came from. Because sometimes, 5 minutes from now, you're doing more work. You might forget where this came from. So let's be organized about how we're going to label this. So let's call it the mid, whatever. You call it whatever you want. Just make sure you know where it came from. So this is 2 pi r h. 2 pi r is 1.25. H is 14.8. You like it when it's blown up like that? Okay. Two pi button times 1.25 times 14.8. I got 116.2389. And what unit is this? Square unit, okay? Now, I got to do this second shape. I'm just going to change colors. Okay, now I got to work on this shape. The big cylinder. So what's missing on the big cylinder? This piece, right? That circle. So it's basically a normal cylinder except for that little piece that you can't see, right? Okay. And is this cylinder the exact same as this cylinder? So once I have the surface area for 1, I can just times by 2. So let's just focus in on one of them, okay? All right. So let's just do it normally. 2 pi r squared, that's the two circles, plus 2 pi RH, 2 pi, radius is 6, 2 pi, radius is 6 times 6.4. Okay, I got 467.4689 square centimeter. So that was if there was no problems. Okay. What do I need to subtract? I need to subtract this little circle here. Okay, what are the dimensions of that little circle? The radius is 1.25, right? Okay, so now I need to subtract small circle. Okay. So that area is pi r square. The radius is 1.25. Pi times 1.25 times 1.25, I got 4.908 square centimeter. Now the composite, I would go 467.4689, take away 4.908, jump into the calculator. And I'm not lazy with decimals so that I never have issues with rounding or accuracy. Because if you take at least 3 decimals, you'll always be okay. Because in high school mathematics, they always just ask rounding to the first and second. So if you always take 3, you'll be good. Okay, I got like 462.5609 or something like this square centimeters. Okay, so that is the surface area of the dumbbell on the right there, that weight on the right. And there's 2 of them, so we'll times that by 2, and you'll get your final answer. So times this by 2, I got, and they wanted it to the nearest whole unit, so 925 centimeters square. Question. Add the other surface area to it. Oh yeah. So the final answer would be a combination of this. Thank you, Mr. Bailey. So sum those. So 116.2389 added to 925, I got like 1041. It's because of that Rockstar you're drinking. Keeps you on top of the math. Yeah, when I was in university, before a big math test, I had one friend that we did math together. And we would walk around before we had to write the test, we would walk around. It was just a big square. We'd walk around and we'd just drink a Coca-Cola right before the test. We would like a bottle of Coke each just right before the test. And you go in there jacked full of caffeine and then write it all down and you're good to go. Because in small spurts, caffeine really helps the brain. Okay. There's number 1. You guys feel okay about that? You need a drink. Go get one quick. Okay, so like most problems in math, if you could just read it and get it down, then you could solve the problem. Sometimes we have issues with reading, okay? So let's take a look. A ball, what shape is the ball? Sphere, okay? Fits tightly within a square box. What's a square box? Cube. So we have a sphere and a cube. So that the side length equals the diameter of the ball. Side length equals the diameter of the ball. Can you guys imagine that? Imagine a sphere where when you put a ball in it, it fit perfect. Okay? Good luck drawing this. Good luck drawing that. Fits perfect. So like the diameter of the box, or pardon me, the diameter of the sphere equals the side length of the box. Then it says how much air surrounds the ball within the box if the box has a side length of 10. So x is 10. So what it's asking is, and I'll use blue to represent air, it's all the space that's not covered by the sphere. Have you guys ever bought tennis balls from Canadian Tire or anything like that, and they come in those tubes? Yeah, so it'd be similar. The tubes, or the tennis balls fit snug in the tubes, and there's this little space outside of the balls. Okay? So when they're talking about how much air, are you talking surface area or volume? Yeah, you guys are good at this. So let's find the volume of the cube. This is the large space, right? So volume is 10 cubed, 1,000 cubic centimeter. And then you do the volume of the sphere would be, what is it, 4/3 pi r cubed. So this is the small space. So we got 4 divides 3 in a bracket times the pi button times the radius cubed. And because I'm lazy, I just go 10 times 10 times 10. I don't even need to hit the power button. I get 4, 1. This doesn't make sense. Oh, because I used, what did I do wrong? 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 I didn't write it down. I said it out loud. I said 10 times 10 times 10. What did I do wrong? Yeah, louder? I used 10, which is the diameter. That was my fault. What am I supposed to use? 5. Okay. So, because I got 4,000, which is bigger than 1,000. That's the small space, so the logic didn't make sense. Okay. So sometimes in math, you just get a little ahead of yourself, and you get a final answer that doesn't make sense. Go back and double check, okay? And I'll just write it in this time, so because I went a little bit too fast for myself. I went a little bit too fast. And it's okay to make mistakes. This is how we learn. 4 divides 3 in a bracket times pi times 5 times 5 times 5. I got 523 this time. 0.598. Okay, now I can subtract these two. Okay, so let's call this volume 1, let's call this volume 2. So total, or not total, because it's not really a total, is it? I'd be like leftover. Leftover volume equals V1 minus V2, 1,000 minus 523.598. and it wants it to the nearest tenth. Like right before I do my final answer, I always just double check the last sentence of the word problem. Nearest tenth would be 0.4, 476.4, and the unit is cubic centimeter. Good. All right. So that's it for the lesson.